So this is Algebra 2, Section 1.6b. This is the last new material. Keep in mind that we have a formative quiz tomorrow on sections 1.5 and 1.6, and then we are getting ready for a test on Friday. Okay? Have your Chromebooks with you tomorrow, all charged up, ready to go? All right, so we have been solving absolute value equations, and we've been talking about breaking out of jail as kind of our analogy of how we get outside those absolute value bars. We can look at the same thing with absolute value inequalities. When we defined absolute value yesterday, we said it was the distance from zero, correct? So if I gave you a number line and said, I want the absolute value to be less than 5. What that means is I'm looking for values for x that are closer to 0 than 5 spaces. Okay, their distance has to be closer than 5. So if this is 0, positive 5, negative 5, I'm looking for the values in between those two. Yes? Okay. When we talk about an absolute value being less than something or less than or equal to it, it is an and problem. Remember we talked about the ands and the ors? Okay, so less than is an and. If you want to think of it as instead of less than, you can think less than, put a D on the end of that, and that's going to help you remember that it is an and question. Okay? All right. What that means is we are looking for an interval in between two endpoints. So we would say the absolute value of x being less than a means it is somewhere between the opposite of a and the positive version of a. All right, between that negative a and that positive a. Using our new interval notation, we would write it like that. Right? We're wanting the values between a and negative a. And using our interval notation for our graph, we'd have those rounded brackets. Okay? When we talk about an absolute value problem that is greater than or equal to, we are thinking of an or problem. Okay? So, way to remember that. Spell it greater. It's an or problem. So we have less than being ands, greaters being ors. Okay? So if I said I wanted the absolute value of x to be greater than 5, where on my number line could I be? If I want to be greater than 5, now I'm looking at sections that are over here or over here, correct? I want to be farther away. So greater, we're going out. Less than, we're coming inside. All right? So for this, I could say that I'm going from negative infinity up to the negative a, or I'm going from positive a up to positive infinity. I'm looking at those two intervals on my graph. Okay? Now, I used a 5 here, but it could be any number, right? Whatever they gave me. So this would be absolute value of x being greater than 5. We're going away from 5 and negative 5. Yes? Okay. Now, if I asked you to write this statement for this chunk right here, we're saying x is bigger than 5. That's this part. This is where most students get mixed up because they want to put the greater than symbol on both ends. But if you think about it, if you're going to the left of negative 5 here, you're going to smaller numbers, right? The further negative we go, the smaller the number is. So we want x to be smaller than negative a. We want to be bigger than positive a, but we want to be smaller than negative a. That's what gets us to the outside of our number line. Okay? With the and question, we're actually doing the same thing. We're flipping the sign when we put the negative a piece in there. So for this one, we want to be smaller than 5, which fits with what we're saying here. But we want to be bigger than negative 5. Okay? But because it's an and question and we can scrunch it all down into one compound statement, we're saying x is smaller than a, but x is also bigger than negative a. But our symbols look the same because we would read it from left to right. Negative a is less than x, which is less than a. Okay? So most students do fine on the less thans because your two symbols here are going to match whatever you have here. But when you have to split it apart, you have to remember to flip that one for the negative. All right, let's try a few. This first question just says, write an absolute value inequality and graph the inequality on the number line. We want to represent a person's checking account that varies between $4,000 and $10,000. Wouldn't that be nice to have a checking account with $10,000 in it? Yes? Okay. So how would we show that we can go between 4,000 and 10,000? Let's start with the number line. What would that look like? Where are we on our graph? Okay. So, sorry. Can we actually equal those? It's tricky when they say the word between, because it's hard to know, are they strictly saying in between those values, or could we be at the endpoints? All right. On a test, we'd be more specific, wouldn't be as ambiguous as that. But we're looking at values in between here, correct? Okay. So for this one, we want x to be greater than 5. Sorry, the absolute value of x to be greater than 5. We used this as an example a minute ago. Where on the number line do we want to be? Okay, so our key numbers would be the 5 and its opposite. Okay. Are we looking at being in between those or being outside of them? If I want to be farther than 5 spaces from 0, and here's 0, right? Then I'm looking at things like 6, 7, 8, right? 5.5. Okay, so we want to be over here or we want to be over here? Yes? What kind of brackets? The rounded ones or the squared off ones? Rounded ones? Okay. Now, in terms of writing that out algebraically, when we split this up and we go to our two escape routes, one of our routes is going to look just like what you see on there without the bars. Okay? So my positive route would be that x has to be greater than 5. Okay? Now, it's a greater, so this is an or problem. X could also be what? Less than the negative 5. Does that make sense? All right, and there was nothing inside the absolute value where we had to solve anything, right? It was just a plain x. So that one's done. This next one, we're saying now we want to be less than 5. So we're picturing in our mind getting closer to 0, right? We're looking at that inside stuff. But we have an expression in here. We have 4x plus 3 that's trying to break out of jail. So again, two escape routes, 4x plus 3 One of yours is going to be exactly what you see, less than 5. And one of yours is going to flip and be negative, so greater than negative 5. But this is an and problem, right? Less than. With and problems, we have an easier way of writing this. We can still show those two escape routes, but we can write it as one big compound inequality. Okay? So instead of this, I want you to get used to putting it in one compound statement. That 4x plus 3 has to be smaller than 5, and it has to be bigger than negative 5. Okay? We solved some of those last week, right? What's my first step? Okay, and we do have to subtract it from all of these, right? Because we're solving both inequalities at once. So 4x is now in between a negative 8 and a 2. When we divide the 4, we have negative 2 is less than x, which is less than 1/2. So for all values of x that are between negative 2 and positive 1/2, my inequality statement will work. When I dump values from this back in here, it will give me an absolute value that's less than 5. If you aren't sure, could you check? Give me a number between negative 2 and positive 1/2. 0? Okay. If we put 0 in here, 4 times 0 is 0, plus 3 is 3. Absolute value of 3 is 3. Is 3 less than 5? Yes. Okay. Give me another number between negative 2 and positive 1/2. Negative 1. Put a negative 1 in here. 4 times negative 1 is negative 4, plus 3 is negative 1. Absolute value is 1. Is 1 less than 5? So the numbers we're getting work. Does that make sense? So for our graph, we need a negative 2, we need a positive 1/2. We're saying we want all the values in between those. So for my interval notation, I'm going to say I could be anywhere between negative 2 and positive 1/2. What would be different in my initial inequality statement if I wanted square brackets? How would it be different? Yep, there'd be an equal to sign underneath it, right? Less than or equal to, greater than or equal to, then we'd have squared brackets. Okay, our next question. Do we have any guards? Yes. So just like yesterday, we have to get rid of the guards before we break out of jail. So we're going to add 5, which means the absolute value of 3x plus 2 now has to be greater than 17. Okay? Greater is or, right? Greater. We want to be farther away from 0. We're picturing going out from our center of our line. Yes? So we have to split this into two parts. If I'm going to be out here, right, and out here, I can't scrunch that all into one compound inequality like I did on the last one. I have to keep it as two separate pieces. So we're going to break out of jail and write our two escape routes. 3x plus 2, 3x plus 2. I want to be farther than 17, right? Farther than 17, or I want to be to the left of negative 17. Yes? So I'm going to be less than negative 17. So I have 3x plus 2 is less than negative 17, or 3x plus 2 is greater than positive 17. All right, go ahead and solve those. check your work. Are we getting the same answers? So we want to be greater than 5. We want to be smaller than negative 19/3 or negative 6 1/3. Okay, so my final interval, I can go from negative infinity to negative 19/3, or, remember that union symbol? Or I can be anywhere from 5 up to positive infinity. All right, our third example. Do we have any guards? Okay. How do we get rid of that guard that's showing up as a 3/4? Multiply by reciprocal. So we're going to multiply both sides by 4/3. So we have the absolute value of x plus 7 is less than or equal to. 3 goes into 24. How many times? 3 goes into 24 8 times. 8 times 4 is 32. So 24 times 4/3 would be 32. Is this an and or an or situation? And, less than, right? It's an and. Ands are the ones that are pointing in, right? On our number line, we're looking for stuff in between two endpoints. So we're going to split up into our two escape routes, but we're going to write it as one big compound statement. So x plus 7 could be less than or equal to 32, and at the same time, it has to be greater than or equal to negative 32. We need to be in between that negative 32 and that positive 32. All right, subtracting 7 from both sides. What do we get for values for x? Agree, disagree? Okay, so we are in between negative 39, positive 25. What kind of brackets? The squared off ones, and we're shading everything in between here. So for my interval statement, my answer, I'm going between negative 39 and positive 25. Okay, I'm going to pause the video before we do the last little bit. I want you to check in with the people at your table, make sure you are all clear on what we've been doing. All right, our last topic here is something called tolerance, and it's discussed in this section because it can be set up as an absolute value inequality. Okay? Tolerance is the maximum allowed minus the minimum allowed divided by 2. When we talk about tolerance, we're saying, for example, I want a piece of string that is 6 inches long, but I'm okay with it being a little bit bigger or a little bit smaller. Just has to be about 6 inches. Does that make sense? I have a tolerance. I'm allowing it to go a little above or a little below. Okay? We can write these as absolute value statements, and in your notes I'd make those a little bit darker and longer so you can really see that they're absolute value bars. If we say x minus the desired amount, what we truly want it to be, all right, I wanted the piece of string to be 6 inches. But I can say that x minus that, so whatever it actually comes out to be, minus my initial 6 inches, it has to be within, in between, whatever I set as my tolerance. Okay? So this is your final amount, subtracting what you truly wanted it to be. That's got to be within that tolerance. Okay? So, for example, on this one, it says write an absolute value inequality and a compound inequality for a length of 24 feet with a tolerance of 3 inches. Okay, so now I want something to measure 24 feet. I'm okay with it being 3 inches above or below that. Okay, now be careful here because one measurement is in feet and one measurement is in inches. How much of a foot is equivalent to 3 inches? A foot is 12 inches, right? So 3 would be a quarter of that. So instead of 3 inches, I'm going to think of this as 1/4 of a foot so that everything's in terms of the same type of measurement. All right. What do I want the length to be? 24 feet. So I'm going to say whatever my final amount comes out to be, if I take away the original 24 feet that I wanted it to be, I have to be within a quarter of that, a quarter foot. Okay, so my statement, my absolute value inequality is that x minus 24, absolute value of that, has to be less than or equal to 1/4. What would it look like if I break out of jail and write it as a compound statement? Now x minus 24 has to be within what? Between negative 1/4 and positive 1/4. Yes? So x has to be in between. If I add 24 to both ends, 24 minus a quarter would be 23 3/4. And 24 plus a quarter. I'm okay with you using decimals if that's easier for you. Okay, so 23.75 up to 24.25. On my graph, I know that I'm in between those values. So my inequality, or sorry, my interval statement is I'm 23 3/4 up to 24 1/4. Okay? So I'm basically saying I can go 3 inches above or below it. Yes? All right. It says in car racing, a car must meet specific dimensions to enter the race. Suppose the desirable height is 52 inches, but cars will be accepted as long as they are between 51 and 53. Write an absolute value inequality to describe the cars allowed. If 52 is what we wanted it to be, but we're allowing it to go up to 53 or down to 51, what's my tolerance? Tolerance, remember, was max minus min divided by 2. So 53 minus 51 divided by 2 is 1. I am tolerant of 1 inch. I can go 1 inch above or 1 inch below. Does that make sense? Yes? Okay. It says write an absolute value inequality to describe the cars that are allowed. We're not solving this one. We're just being asked to write the inequality. So the absolute value of x minus, what did we want it to be? We wanted it to be 52. We are tolerant up to 1 inch. Does that make sense? We're okay going 1 inch above or below it. All right. So we are looking at writing and solving absolute value inequalities. Your homework today is 1.6b. Question 34 is written on here. I'm going to pause the recording for a minute. I want you to try that one first because I want to talk about what happens on that one. Okay? All right. How is this one different? Yes. Yeah, we're not used to seeing that negative. Now, if this was an equality, an equation, where it said the absolute value of 2x plus 1 has to be exactly negative 9, we say there's no solution, right? But with an inequality, there's a range of numbers. We can maybe find something that would work. So let's break it up. It's a greater, right? So my two statements, I'm going to have 2x plus 1. One of my solutions looks exactly like what I have here without the bars, right? It can be greater than or equal to negative 9, or we can flip it and do the opposite. So it could be less than or equal to positive 9. Does that make sense? So remember, the one on the right side, this one over here, always looks just like my original problem without the bars. On the other side, we have to flip it and change the sign. Okay, solving it, subtracting 1 and dividing by 2. For this one, subtracting 1, dividing by 2. Okay, now it is an or situation. So this is telling me I need a negative 10, I need a 4 as my numbers. The first statement says x can be 4 or anything lower. Yes? So I'm here going this way. The other statement says x could be at negative 10 or anything higher. Sorry. Thank you. Negative 5. Okay. But what have I shaded? Is there anything on my number line that isn't shaded? It's an or situation. It means I could be on either of my shaded things. I could be from negative 5 going up, or I can be from 4 going down. The effect of that is that I shaded the whole line. Yes? Now, this was a greater. If it had been a less than, I would be looking for where they overlap, right? This is asking for any of it. So my answer here is all real numbers. I can be anywhere from negative infinity to positive infinity. Anything will work. If you're not sure, could you plug some different numbers in and see if they always come out to work? Okay. All right, so homework tonight then is 1.6b. We already did question 34.